Assalamualaikum and greeting everyone. My name is Fatasha binti Fuad. I'm from UiTM Police. I will be presenting my final year project entitled Coagulation Behaviour of Humic Acid using Polyaluminium Chloride under supervision Dr. Zaidi Abdul Ghani. My presentation will be consist of 5 outlines, which are Introduction, Literature Review, Methodology, Result and Discussion, and lastly, Conclusion and Recommendation. Water is necessary for living things to evolve on the earth. Water which is clean and easily accessible is important for health. About 90% of all organic substances live in surface water, such as humic acid, fulvic acid, and humins. Ruka, Woska, and Pisit stated that it cannot be consumed without pretreatment since it can cause of water dissipation by products such as trichloromethane and chloroacetic acid, causing a direct health chance of exposure consuming polluted waste. To eliminate humid substances from water, the coagulation process is widely used. This procedure also can extract most bacteria that are suspended in water and can even extract color from water. According to Malvi, Maliki, Rizzi, and Safari, natural organic matter is a complex matrix of organic compounds found in natural surface water bodies. It not only influences the odor, color, and taste of water, but also affects many drinking water disposal systems. Natural organic matter may be harmful to marine species at elevated concentrations, posing health hazard to humans if they are actively exposed or bioaccumulating across food chains. There are two main objectives of this study, which are firstly, to determine the effect of coagulant dosage, concentration, pH, and different types of coagulants on the coagulation of humic acid. Second, to examine the relationship between water quality parameters and coagulation efficiency. Chemical coagulation is chosen as the method to eliminate humic acid substance in water, since it can separate large particles from water, resulting filtration membranes will not fall, tear, or clog as quickly. A natural coagulant must be applied to the solution to neutralize either a positively or negatively charged effluent for this treatment step to occur. This study carried out several experiments to determine some of the parameters when removing humic acid from surface water, such as coagulation tests for dosage, concentration, pH, and types of coagulant. Other than that, the absorbance of humic acid was measured by using UV-based spectrophotometer. Lastly, chlorometer was used to examine the water quality parameters, which are turbidity, suspended solid, apparent color, and true color. The significance of this study is to reduce the increase of natural organic matter from surface water and municipal water that has been reported worldwide by using polyaluminium chloride as coagulant. Thus, by doing water purification, the contaminant from wastewater can be removed, resulting in clean and safe water for living things. Natural organic matter characterization. Natural organic matter is generated primarily by the weathering or decomposition of terrestrial plants and as well as a byproduct of bacteria, algae, and aquatic plants. Natural organic matter is a very complex combination of organic molecules with aromatic, aliphatic, phenolic, and quinolic functional groups that may be found in both groundwater and surface waters. Although natural organic matter is not lethal, its presence in water, particularly drinking water, is very hazardous. Humid substance is bound to dark-colored combination of complex organic chemicals that are typically fractionated into three fractions based on their water solubility, which are humic acid, fulvic acid, and humin. Humic acid is a heterogeneous molecule which segregated aromatic and aliphatic moieties as well as significant percentage of oxygen containing functional groups. Fulvic acid have a smaller molecular weight, lower pH sensitivity, greater solubility, a structure richer in oxygen compounds, and lesser aromaticity when compared to other fractions of humic substances. Humin is low solubility derived from its strong interaction with inorganic salt colloids, particularly swelling, glaze, and iron complexes. 2.2 Methodologies of removing humic acid. First, coagulation theory. Chu et al. Stated that coagulation is the process in which fine particles are mixed to form larger aggregates, which is called plugs, and dissolved organic matter is adsorbed onto particulate aggregates to be removed in later solid or liquid separation operations. Second, enhanced coagulation. According to Sun et al., one of the mechanisms of increased coagulation is the formation of an organic positive layer on the surface of inorganic colloidal particles by macromolecular natural organic matter. Third, flocculation. Flocculation is a water treatment technique in which particles combine to create bigger clumps of floc which are then removed from the water. 2.3 Factors affecting of coagulation. There are 4 factors that affect coagulation. Firstly, the effects of coagulant dosage on the coagulation. Second, the effects of concentration on the coagulation. Third, the effects of pH on the coagulation. And lastly, the effects of coagulant types. 2.4 Natural organic matter analysis techniques. Trial testing is an experimental analysis of the treatment chemicals employed in a certain water treatment. It stimulates the coagulation, flocculation process in a water treatment plant and assists operators in determining if the proper quantity of treatment chemical is being used, therefore improving the performance. The methodology. The synthetic test water was prepared by diluting 400 ml of humic acid salt solution to 4 liters with distilled water. Next, the coagulants were prepared based on each of the amount weighed and diluted with 100 ml deionized water except polyaluminium chloride. Then all coagulation tests were carried out in 1 liter beakers with a standard jar test setup. The flocculator rapidly mixed at 200 rpm for 2 minutes, stir gradually at 50 rpm for 50 minutes, then gravity settle with 30 minutes. Then around 2 cm below the top surface water, 10 ml supernatant was removed for examination of remaining contaminants. There were 4 experiments that have been conducted. Firstly, polyaluminium chloride was used as coagulant at a concentration of 100 ppm with a variable dose. Second experiment, the stock humic acid solution was diluted with distilled water based on the concentration chosen. The coagulant utilized in the test was polyaluminium chloride with a dose of 0.8 ml being the optimal. The experiment which determined optimal pH was done by using 75 ppm synthetic test water and 0.8 ml polyaluminium chloride with different pH. Lastly, the efficiency of coagulant in coagulation test was determined by using aluminum sulfate, aluminum chloride and ferric chloride as coagulant. Each coagulant was injected to the synthetic test water in 0.8 ml dose with the same concentration and pH of 75 ppm and pH 8. Respectively. The treated sample was further tested for adsorbent at wavelength 254, turbidity, color and total suspended solid by using portable calorimeter and UV spectrophotometer. Effect of coagulant dosage. Bar graph shows that the best polyaluminium chloride dosage was found to be 0.8 ml based on the percentage removal of the parameters. The large turbidity decrease at optimal coagulant dosage is explained by the fact that turbidity increased as soon as the coagulant concentration exceeds the optimum dose since all colloids have already been neutralized and precipitated at the optimum dosage. The coagulant particles destabilize the negatively charged colloids existing in the treated water by neutralizing charge that produce repulsive interactions between colloids. Effect of concentration. The optimal concentration for coagulation of humic acid elimination at the 0.8 ml of polyaluminium chloride is 75 ppm according to the study. As the quantity of humic acid rises, more polymer is required to neutralize the humic acid charge, and fewer segments are available to form loops and tails. Thus, the adsorption velocity reduced and the humic acid removal rate improved marginally. Effect of solution pH. The optimal solution pH for coagulation of humic acid elimination at pH 8, with a pH range of 5 to 9, polyaluminium chloride proved successful in removing DOC from natural humic water. Bridging and sweep flocculation are recognized to be primary mechanism for the removal of natural organic matter at pH level greater than the coagulant minimum solubility. Effect of types of coagulants. Based on the graph, it was shown that polyaluminium chloride had the highest humic acid removal efficiency, followed by aluminum sulfate, ferric chloride, and finally aluminum chloride. Polyaluminium chloride has a high positive electrical charge. It can easily neutralize the electrical charge on the surface of colloidal particles and deal with the reduce of the force repair electrostatically between particles as small as possible, allowing colloidal particles to approach one another and form clots or larger masses. The coagulation behavior of polyaluminium chloride in humic acid solution was investigated in this study. Turbidity, suspended solid, and color were all considered as important coagulation parameters. The coagulation studies with polyaluminium chloride revealed that employing 0.8 ml of the coagulant, the coagulation process efficiently eliminated humic acid from water. pH 8 was determined to be the best range for removing humic acid. In addition, 75 ppm was the best concentration for removing humic acid. The most effective coagulant was polyaluminium chloride, which showed the highest percentage removal for the 4 kinds of coagulant used. Recommendation. Firstly, novel coagulant with high removal effectiveness, cheap cost, and environmental friendliness should be developed as soon as possible to significantly improve treatment performance. Second, the effects of different metal species in inorganic coagulants should be further explored. Third, the further research into the regeneration of adsorbents are necessary to make coagulations more economically viable. And lastly, the combining adsorption with other treatment methods such as advanced oxidation and biotreatment might provide a more realistic choice for increased natural organic matter elimination. That's all from me. Thank you for watching.